In figure, we have two parallel mirrors. So PQ and RS are two mirrors placed parallel to each other. So these two are parallel. An incident ray AB strikes the mirror PQ at B, and the reflected ray moves along the path BC and strikes the mirror RS at C, and again reflects back along CD. So bouncing, bouncing, and this. Prove that we have AB being parallel to CD. Okay, so again, it's too many lines, and you guys know I would prefer to have a separate diagram when things are complicated. So we have two parallel lines in this manner, ABCD, and we have to prove that this is AB, CD. We have to prove that AB is parallel to CD. So basically, if I prove corresponding angles are equal, corresponding, okay, that looks a bit difficult, right? Because the line ends over here. I think it's easier to prove these two alternative interior angles are equal, right? Because ABC and BCD, those are equal. So how do you prove that? See, the thing is, it has to do with law of reflection. So we need to start with that. The law of reflection tells that the angle of incidence is equal to angle of reflection. Okay, so let's begin with that. As per law of reflection, angle of incidence is equal to angle of reflection. What does it mean? See, this is known as incident ray. It's falling on the mirror, right? So incident ray. This is reflected ray. It is bouncing off the mirror, so it is reflected ray. At this point B, you need to draw a perpendicular line. So we'll call this as M. Okay. So basically what this law tells is this angle between the incident and the normal will be equal to this. So these two angles are equal. That's what the law tells. Similarly at this end also. I should have used some other color. So this is B and this is B. That's what the law tells. Okay. So how to do this? We can tell that right, we have to do a bit of construction. At B, draw BN, the normal. Therefore angle ABM is equal to angle MBC, which is equal to A. That's what the law tells. So we'll tell similarly C, draw CN, the normal. Therefore angle BCN is equal to angle NCD. So this angle is 2A as per this, and this angle is 2B. So if I prove that 2A is equal to 2B, we are done. Okay, so that is our agenda. Right? Should we write anything else? We'll just mention that we have been given that PQ is parallel to RS. So now we have to depend on PQ being parallel to RS to prove that 2A is equal to 2B. So let's figure out that. So as usual, I will draw a separate diagram. And the transversal line is that. So we have RS, and that's C. Then we have PQ, and that's B. Okay. Now, so what do we do? What do we do? What do we do? What do we do? How do we go about it? Think. We can make use of the alternative interior angles. So we'll call this as theta and this is theta, right? So these two are equal. So basically this is theta and this is theta. But we know that this is 90 degree. So this is theta minus 90 and this is theta minus 90. So this both are theta minus 90, theta minus 90. So 90 minus theta. So basically A is 90 minus theta, B is 90 minus theta, and you are done. That's it. Okay. I'll show the writing. So we'll tell as proof continuation as PQ is parallel to RS, angle CBQ is equal to angle BCR, which is equal to theta. So these two angles are equal. Then this we are calling it as M and N. M and N. So angle MBQ, which is A plus theta, which is also equal to 90 degree, right? Is it not? So A will be equal to 90 minus theta. Then we have NCR, angle NCR, which is B plus theta, which is equal to 90 degree. They are perpendicular, is it not? So B is equal to 90 minus theta. Okay. So from this two equation 1 and 2, so what can you tell? So from 1 and 2, so from 1 and 2, we have angle A is equal to angle B. So if I multiply 2 both the sides, 2A is equal to 2B by multiplying 2 both sides. So this, okay, that's it, right? We proved it. Since 2A is equal to 2B, AB is parallel to CD as their alternative interior angles are equal. Okay. So, oh yeah, this we should write it as alternative interior angles. Now, AC is parallel to AB is parallel to CD. I hope I'm writing it right. AB is parallel to CD, correct? As alternative interior angles are equal. Okay, so this is your answer, right? So this has to do with law of reflection, so that if you make it clear, this is 2A and this is 2B, and next is that these two lines are parallel, so we have alternative interior angles being equal as theta theta, and next is perpendicular lines, so consider that, and you'll get an expression for A and B in terms of theta as 90 minus theta. Since they are equal, 2A will be equal to 2B, and so since the alternative interior angles are equal, those two lines will be parallel, right? A lot of writing, I agree, but if you think about it, logically it's not that much. So pause and please copy it off.